user of Pro Engineer for a very, very long time and recently moved on to the all-new Creo platform. So that all sounds good to everybody. I suppose we'll just crack on. So just by way of agenda, I'd really like to talk about what we really mean by design agility, and specifically what we mean by design agility when talking about the MCAD world and the world of parametric computer-aided design. I'd also then just like to move on to show you really what that looks like, how it works, and some of the benefits which we can then bring to the business. And finally, just finishing off with a Q&A session, asking the many questions which one would hope will come through in the chat box within the GoToWebinar dialogue. So, what does PTC mean by design agility? Well, that's really all about working with market pressures. Now, we all need to do more with less in this day and age. We all work in a 24/7 environment. We work across multiple geographies, multiple languages, and multiple tools. And to be successful in that environment, we need to be agile with the contents which we create, which actually ultimately drive products and drive those products to market. Now, what the PTC thinks about when we talk about the need to be agile within the engineering environment is really around doing things like improving productivity and creating concepts. Parametric CAD is tremendous at laying down intelligence and laying down geometry. But when I want to change that, it's not often that easy. So if I can do that very quickly and easily, then surely my productivity will increase, my creativity will also increase. We also often need to generate geometry very quickly in the bid and proposal world. I don't want to be investing a lot of time and intelligence in generating a new concept when I may not even win the work. So consequently, I need to be agile enough just to generate a concept and push that out to the bid world. We also need to support more and more in this day and age digital prototyping. Actually having a physical prototype before I've done any tooling and before I've potentially even won the bid. But often that digital prototyping requirement, it requires me to defeature models and simplify geometry so that I'm not necessarily giving away IP or indeed generating geometry above and beyond the needs of the machine. Design reviews are also a classic place where I need to be much more agile because I can severely impact the timescale of design when I'm looking at reviews and looking at design alternatives. Certainly the number of times I've been in design reviews and project managers have come along and said, oh, can you just change this, can you just change that? And because I haven't thought about the project manager wanting to make those changes to any particular design, I haven't been able to do that in the parametric world. So surely if I can accelerate my design review, reduce the time, give more ideas, again, I can be more agile. We also, again, in this day and age, need to be able to work with legacy data and also work with other CAD systems. So we need to improve the interoperability and data exchange between CAD systems. It's no good anymore just pulling geometry in from other systems and it's done and you can't change it. I also need to be agile, particularly at the late stage when time pressures are very, very much at the forefront of my mind. I want to be able to very quickly make changes to geometry, not necessarily having to think about the previous design intent with the model. I also maybe want to accelerate the CAE workflow. When I push content over to my analysts, I don't want them having to figure out how I've built the model. I just want them to be able to work with the geometry, create the analysis, and give me the information which I need. And also maybe speed down the creation of downstream deliverables. Maybe IGES files out to suppliers. Maybe simplified space models for people to use my models in their designs, but without giving them all of my IP. Now, for me, being a design engineer, some of the real key areas which I think that the flexible modeling capabilities can really help me is around accelerating my design reviews, being able to just push and pull geometry around as I need. And when I'm talking about pushing and pulling geometry around, again, the ability to just put in 3D CAD from anywhere. whether it be SolidWorks or AutoCAD or whatever. I can pull that geometry in, build intelligence, and reuse it. So, and finally, really the ability to simplify my CAE workflow. Being able to just give some geometry to my analysts and let them modify the geometry, but not having to think about all the design intent that I've built in previously. Now, obviously, there's an awful lot of capability needs there, and clearly, we can't do everything all at once. Now, that really means that often this agility is very much out of reach. So we actually reached out to the industry, the MCAD world, and really asked our users and other users what their challenges typically were. And from that, we could then start to develop product. So the first thing that the polls told us was that late-stage design is not easy. Often people need to do big changes right at the last minute, and that means that they either need to work late or cannot go on vacation. So consequently, we've got to do something about making late-stage design easier. They also told us that typically design is evolutionary, not revolutionary. So they want to work with existing data and just move it around rather than reinventing the wheel. And by far the vast majority, 60% of our users are having to work with data from multiple CAD platforms. This is not an easy thing to do if I'm, first of all, having to import it and have problems importing it, but when I have imported it, it's just done, and maybe I want to build some intelligence into that. And finally, 1 out of every 6 users said that defeaturing models was really, really difficult when either exporting it to third parties or exporting it just across the CAE chain. So what can we actually do to help you with these kind of challenges? Because to be successful in this marketplace, which is particularly competitive at the moment, we need to be much more agile, and we need to therefore address these challenges which we're seeing across the marketplace. So let's just do a quick deep dive into what each one of these 4 things means. So first of all, late stage design changes. What does that actually mean? What's the impact? So first of all, I need to make a last-minute change to a parametric model. I haven't necessarily anticipated this, but typically that's going to be difficult for me to do because when I make that change, I'll have impact all across the model. I don't necessarily have time to worry about how that parametric model was built, or indeed the requirements have evolved, which means that that design intent has changed from when I first started to build that model. Now, what I really don't want to do is have to remodel everything. I don't want to have to think, right, these are the new parametrics, this is the new requirements, therefore I'll build it from the bottom up. I just want to maybe move some bosses, move a hole, move some ribs, etc., etc. So I can then go on and either analyze the thing or get the thing made. And of course, in the world of parametrics, all my cutter toolpaths would all update because that's all linked directly to geometry. Now, nearly a third of our users said that they had significant challenges with late-stage design. Now, you've got a choice here. You can either work late, miss your holiday, or deploy some additional technology supplied by PTC. But what's the answer to this? Well, the answer to a greater or lesser extent is pretty simple, and that answer is Creo. With Creo, we can easily make these changes without losing any of the original design intent. So with flexible modeling, we can directly modify geometry from any CAD source, and that's really key, that we're directly modifying geometry. Now what that means is we're building direct modeling capabilities into ProEngineer, or Creo, parametric as the case may be. Now when we're laying down features in Creo parametric, you're already building that intelligence. You're building a formula which results in geometry. So for you old school users out there, you'd say, right, I want a protrusion, it's going to be one side, it's going to be from this datum plane. I'm going to sketch something, I'll extrude it by this distance, I'll add taper, etc., etc. So you're building a formula which results in geometry. When I'm directly modifying geometry, I simply select that geometry, drag it about, pull it around, change it as I see fit. So I'm directly modeling on the within ProEngineer. I also don't need to rework that design intent because it's adding features. So that original design intent is preserved. I don't need to, I'm not removing any information which has previously been added to my model. Design is also evolutionary, not revolutionary. So when I'm talking about evolutionary design, I want to be able to quickly create new concepts on existing parametric models. Now, that again can be challenging because those new concepts may not necessarily have been parameterized for me to move geometry around because I don't necessarily have a dimension. And those new design requirements really mean that the initial design intent is obsolete. So what I'd really like to be able to do is rapidly modify the existing design, without losing any of the intelligence, because I may want to rework that later on, but I also want to be able to put new intelligence into the model. So what our users said there is that 70% of them that said that they partially or heavily used existing concepts they used existing designs for new concepts. But that in itself is very challenging because I may have to rework many of those features and think about parents and children, think about the references which I'm building all the time. So again, how can we enable us to generate evolutionary design rather than revolutionary and reuse existing content which has been authored either in Creo Parametric or anything else? And again, the answer to that is Creo. So with Creo, we can really easily modify existing parametric models for whatever purpose we like. We can simply select geometry, and bear in mind I'm talking about geometry here and not features, and push and pull that geometry around in very interactive ways. I'm also not losing the previous design intent because I'm building on the existing parametrics. I'm building new features. And because I'm building new features, that means all that capabilities which you see inside Creo Parametric with the likes of family tables or use-defined features or interchange assemblies, all that good stuff, that all still works because I'm simply adding parametric features which are, for example, moves or warps, etc., etc. Also, because I am doing this kind of on the fly, I can really accelerate my design review. So I can very quickly work out what-if design scenarios and repurpose my existing Creo parametric content for other purposes. Now we're also working more and more these days with third parties, working more and more with third-party design. And often, if you look at any product, there'll be content in there from Creo, from SolidWorks, etc., etc. And all of these need to work together. And this can be a real significant challenge to my user. In ProEngineer, you have the ability, as you can see over here, to open up all sorts of content, whether it be SolidWorks or Inventor or Unigraphics or V5, V4, etc., etc. You can open it, but the issue that you have is that that can be problematic with the import. But secondly, all the design intelligence which was housed within that model is lost. It's simply done. I don't know anything about my fits and any of my fits. I don't know about my tolerances. I don't know about how things were dimensioned. But more critically, I can't change anything. And if I'm working with legacy content, that's even more important, because working with legacy content, I may very quickly want to have to repurpose that to get another iteration of the drawing out to resolve some issue in the field. And talking to our users, about 60% of people said that they had issues when modifying models imported from other CAD systems. Okay, so we need to clearly do something about these things. And again, what's the answer here? Well, I think that there is a pattern emerging. The answer is, again, Creo. So with Creo, we can easily use CAD from any system. Even if we pull out some of those extraordinary systems from way back when, Payfect Dogs, for example, or Duct Draft, as long as it's a format which we can open up in Creo Parametric, then we can work with that information and modify it. So if we if we open that content, we can start to intelligently build design intent, whether that be through looking for patterns, whether it be through looking for lines of symmetry or planes of symmetry. Once we've then identified these, we can start to build parametric features by saying, this hole is this big and this hole is dimension from here or dimension from there. But I'm simply repurposing the content and not recreating it. The fourth location where I think design agility is absolutely key is around defeaturing. Now, if you want to give a model to an analyst, for example, or maybe just simplify the geometry, that can be kind of difficult because of the parents and children related within any given model. So often I'll want to take a model and maybe simplify it just by getting rid of geometry for either design optimization so that runs more quickly, or for simulation tasks where there are bits of the geometry that I'm not interested, or indeed for NC tasks where I'm either happy that content isn't going to be modified or worked with. But I do need to simplify this information to share it certainly with partners, but also people within my business as well. And again, nearly 20% of users said that this kind of validation and verification really found the CAD tool a struggle, because as an analyst, they're not interested in how you put your models together. They're interested in the geometry. So they want to be able to modify that geometry and not modify your existing features or have to repurpose your existing features. They just want to say, move this boss from the left to the right, create a new boss, change the dimensioning scheme, remove some geometry so it runs more quickly. All of that stuff is all possible with Creo, because again, the answer to the world of defeaturing is Creo. So we can very simply select geometry and just get rid of geometry for downstream deliverables. So there's less reliance on the CAD guys. There's much more reliance on what the geometry looks like. Now, really that means that the design intent doesn't need to be understood to edit the design itself. And of course, because this is just adding additional features to the model tree, that really means that as we go through and add content, we'll see that we've got those features which can be removed or suppressed, etc., etc. And again, because it's just adding features, we can work with data from any CAD source. It doesn't need to actually understand what's going on. So we've said that the answer is Creo. Let's do a bit more of a deep dive into what that actually means, what Creo looks like, and whereabouts in the Creo toolset this capability really sits. But I'm sure we can all see that if we can be more agile with our design, if we can address some of these challenges, then clearly there is significant benefit to the business by reducing timescales, by hitting markets sooner and really capturing market share with our new products. So let's have a look at Creo. What is it? Well, in a nutshell, Creo is a suite of bite-sized applications which are completely integrated together, so they're completely interoperable. And what that really results in is 4 breakthrough technologies which PTC have branded any role apps, any mode modeling, any data adoption, and any BOM assembly. Now within these 4 specific breakthrough technologies, there's 2 areas that we're interested in, is any mode modeling and any data adoption. Now what do they actually mean to me? To me, any mode modeling really allows me to work in any mode. Whether I want to work in the parametric mode or the direct mode, I can just work how I want to work. I can lay down geometry and not have to think, right, well, if I'm laying down a parametric feature, I need to make sure I've got dimensions from here to here, and I've got the blend radius sorted, and I've got my X-section vectors right, and all that sort of stuff. I just want to lay down geometry. I want to work directly on geometry, and that's what this any mode modeling is about. I also want to work with any data. I don't want to be forced just to work with pro-engineer content. I want to work with data from any source and build intelligence into that data from any source. And that's really where any data adoption fits in. Now, as we can appreciate, within the Creo product set, there is an awful lot of capability, whether that be from the world of parametric modeling or direct modeling, But we've also got simulation tools and schematics and illustration and viewing tools, etc., etc. So we'll see here that within the Creo 1.0 tool set, we've got parametric, direct, simulation for my FEA layout, schematics for my cable and harness design, for example, illustration to repurpose MCAD content for technical publications maybe. I can also view MCAD content, view ECAD content, and just a really simple sketch tool to quickly lay out information. But whereabouts inside here does this direct modeling, this flex modeling sit? Well, obviously it sits inside the world of direct modeling, but flexible modeling is a subset of the parametric world because it builds direct modeling features into the parametric world. So, looking at that flexible modeling extension within Creo, first of all, it's an add-on. It's a bolt-on extension to Creo Parametric. Now, this means that, like all ProEngineer modules, it floats. So you can have, 1 seat of flexible modeling extension to your 5 seats of ProEngineer and just float that across your all your seats as you need. Now, what is it? It's a set of editing tools. You can't create geometry using flexible modeling, but you can edit existing geometry. But you work directly on that geometry. It's not a tool in which we lay down concepts such as variable section sweeps or swept blends. You simply select existing geometry and work with it. So we don't need to worry about any underlying feature definitions. We don't need to worry about how information was put down in the first place because I'm simply working with geometry. And of course, because it's just working on geometry, it doesn't matter whether it is legacy ProEngineer content, new ProEngineer content, or indeed content from another source, whatever that may be. It also creates parametric features. So as we'll see in my demonstration, as we start to add content into my models, we'll see features added to the tree. And as features are added, we can start to work on those. We can edit them, we can group them together, we can add them to family tables, we can suppress them, etc., etc. They obey all those standard kind of parametric feature rules which we see throughout ProEngineer, which means they're hugely powerful, particularly when I'm starting to think about some of those more advanced features inside Pro, like, for example, UDFs. But I'd just like to reiterate, there is really no new geometry creation within the flexible modeling extension. It's all about modifying existing information, but it is the foundation of all direct edits in Creo Direct. So as you see, for example, as you edit content in, for example, Creo Direct, you'll see flex move features magically appear when I start to work in the parametric world. Now this is really what this goes back to what I was talking about when we start to push and pull data between these interoperable applications, i.e. Creo Direct, Creo Parametric, etc., etc. So I've given you a good kind of 25-30 minute overview as to what PTC think of as design agility. It's really the ability to be very, very agile and very fluid with existing geometry and be able to repurpose that geometry for other users down the food chain. So shall we actually go ahead and look at what this content looks like and look at what this tool looks like within the world of Creo Parametric. So we've got 3 stages to this demonstration. I'm going to look at how we can work with data from any multi-CAD environment. We're then going to move on to have a look at late stage design changes or indeed design reviews. And finally, how we can go about defeaturing models. So, multi-CAD design data. So what we're looking at here is Creo Parametric 1.0, which is the latest incarnation and the latest revolution from PTC in the world of MCAD. Essentially, it's taken all the capabilities of ProEngineer, which changed into Creo Elements Pro, now into Creo. So we're going to start off just by simply opening up some content. You'll notice inside Creo we get the ability to have a look at the thumbnails here. And this is really from any source, whether it be my standard Creo files, or indeed whether it be IGES, step files, or conversely other CAD tools such as CATIA, as we see here, Inventor, SolidWorks, etc., etc. The list just goes on and on. So I'm just going to open up some very simple geometry which I've worked with before. Okay? So this is just a standard kind of IGES file which would have been retrieved from another source. We can see that we've got a little nut and bolt down here, which clearly needs to go through some sort of interference hole. For those users who are familiar with the interface, we've got a set of tabs across the top here, and we've got the model tree over on the left-hand side. So looking at one of these particular components, you'll notice that this component has been imported from a third party, because over on the left-hand side we get to see that it's telling me that it's an import feature, and there's no way in which I can modify any of this geometry. I can't just say, well, I want to move this face or I want to move that face. And this is really where flexible modeling comes in, that I can take content from any source and start to work with it. So up here I see I've got my flexible modeling tab, and by picking on geometry I can simply say I want to take this face and maybe want to move it around. So I can simply take existing geometry and drag it about as I see fit. We support not only single face selection but also multiple surface selection. We've got some really neat selection tools up here which allow me to very quickly pick geometry. So here, for example, I'll just say, well, give me all the objects based upon the cut, and maybe take this end surface as well. And again, let's just move those out. So we can move things together as well. We can also use this content to maybe build intelligence, because clearly if this hole moves, then when I have a look at my assembly, if the hole moves, then there's going to be some form of interference between this plate and this plate. So we can start to build intelligence and build dimensions to understand that intelligence. So, for example, if we just start to build some additional features inside here, so I'll say one of the axes inside there, and we can then start to work with this information inside my world of flexible modeling. So I'll say, well, first of all, I want to maybe generate a move feature there, but rather than just moving it, I'll say, right, I want to move it via a dimension. And when I say I want to move it via a dimension, I just specify, well, I want a dimension between here and here. So we can start to see that I've actually got a number which I can start to parametrically play with. Yeah? And the same with the hole. So if, for example, when I move this feature, I want the hole to move as well, again, we can do that. So again, I'll just say, right, I want to move. Underneath references, I can specify whether I've got surfaces which I specifically want to exclude, or additional datums which I want to move as well. And then again, it's just a question of building up a dimension to specify how I want that thing to be parametric control, whether it be just one dimension, or 2 dimensions, or whatever that may be. So what you'll then start to see is, as we start to build these features, we can see we get these move items in the model tree, which, as you could expect, to be renamed or edited, etc., etc. Or indeed, if I just decide that I want to edit, for example, this first feature, that hole moves with it. But the million-dollar question is, that's all well and good, but what's actually happened to my assembly? How has that impacted on my assembly? Well, as you would expect inside parametrics, as it's a associative modeler, the initial component has moved, and then all the relationships are simply updated to put that component in the right place. So you can see how powerful this is, really working with other forms of CAD data. Now, those edits, I think you'll all agree, are pretty simple things. You could have built some features to do that. You could have, when it was imported, you could have removed surfaces, you could have rebuilt them, you could have sketched things, etc., etc. But what happens when I'm working with more complicated geometry, where that's just simply not possible? So I've got some other information over here in the form of a yoke, and again, this is just an imported feature. Now, this has been supplied to me by a supplier, surprisingly enough, and I need to outline to him that he needs to make some changes. So I'd like these two bosses to be maybe moved around by 45 degrees. I'd also like them to be moved slightly further away from the center. And the other thing which I'm not happy about is where these two holes are. Now doing that by recreating features is very, very difficult because I'd need to measure everything. I wouldn't necessarily know about the surface topology. But again, with flexible modeling, it's really, really easy. So the first thing I can start to do is start to build some intelligence. So I can start to say, well, there's some symmetry going on between, for example, this face and this face. Oops. Between this face even and this face. That looks at where they're symmetrical, how they're symmetrical, and that will build intelligence for later on. So when I then want to maybe move this boss, again I can just say, well, take this face, maybe select it as a boss, so that gets all of those surfaces. So it's a really quick and easy selection tool. And again, I can either move this around via a dimension, as you can see here, or indeed I can just use the dragger that we saw previously. So when I now start to drag this thing around, now I think I want to put some spin on it up here, and we maybe want to drag it that way a bit. Maybe put some more turn on it. Maybe pull it in a little bit. And so that's just a way of pulling some geometry around, but it also understands the existing intelligence which I've previously built. So I can tell it that there's some existing symmetry which it needs to think about. So I can simply tell it, look, there's a symmetry which you need to think about, so it moves them both together. So I can really start to build intelligence into what previously would have been just a piece of dumb geometry. And I can then communicate that back with my partner or my supplier, so he understands really exactly what I want, rather than having to do this via fag packet sketches or via screenshots, whatever that may be. And we could maybe do exactly the same down here with true engineering content. So again, I'll just say, right, I've got a surface in here, and say I want to build some symmetry between these two faces. And now when I take this object, maybe tell it that this time it's a cut because it's removing material. Again, I just want to move that. We can just simply say that there's some symmetry built in there. And again, you'll see how the model tree is being built up. So now when I move this hole, the two holes move together. So, for me as an engineer, working with imported data really frequently, this will revolutionize the way in which I work with suppliers, because that means I can repurpose old content and build intelligence into that, but it also means that I now have the ability to modify content which has been given to me by other suppliers, which previously would have been a complete nightmare to do. It would have taken me a huge amount of time, or indeed just not been tenable. So just moving on to the second part of my demonstration, I want to talk about how we can go about working with this Creo content when I'm working in the context of either late-stage design or design reviews, which typically would have caused me huge headaches when working in the parametric world. So again, let's just get rid of some of these windows. And I've got, again, some pretty simple geometry which I want to work with. So this has been authored inside ProEngineer, and I'm just preparing this content for a design review. And in this design review, I'm pretty sure that my project manager is going to want to talk about where this boss is going to do, maybe move the position of this boss. He's going to ask me to do that. I'm also wanting to move this boss around, which again, shouldn't cause too much problem because I'm in the world of parametric, so it's just a question of modifying dimensions. I'm also going to want to re-look at the way in which this boss is attaching with this side face, because there's a need to move. I know that there's a need to move this way. So we'll have a look at the impact that has on my dimensioning scheme later on. And finally, there's the idea of having a new lug design up here. So I've always been able to replace surfaces inside Pro Engineer, but this is could prove a bit of a problem because there are 3 of them. Well, that's got some problems there. So anyway, let's get on with the design review and see what it brings. So looking at this tank cover, I notice that it's a standard Pro Engineer model. The other ones that have been imported from third parties. This is just a standard Pro Engineer model where we get all the features as you'd expect to see them. You know, we'd see my datum planes, axes, protrusions, rounds, cuts, surfaces, revolves, curves, etc., etc., etc. You know, the list just goes on. So the first thing which my project manager starts to ask me is, you know, I've got this boss and I just want to move it. Well, there's parametric features, so that should prove a problem at all, because I can just change these numbers. But he also says, actually, I want to move this way. I want to move it towards the bottom of the screen. That is going to cause me a problem, because the way in which I've built this thing is that this boss is in line with this boss. Okay, I'm now starting to look stupid. He also wants me to maybe change this to an angle because we've got some clearance issues. Okay, I'm looking really stupid now. That's a big issue. That's not a problem when I'm talking about flexible modeling. Within flexible modeling, I can simply take some surfaces. So maybe say I want to take this boss, maybe take this internal face, which will be a cut. Yeah, so you can see I've got all that geometry sorted. And again, I can just move that around. So when I move it, it's not simply moving the geometry which you select. It's actually doing an awful lot of topology checks and changes. Because as we pull this to the side, you would expect that there'll be changes made to this round. And you'll notice there that the round is indeed changing. You know, it's not just putting that geometry straight off the side of the surface. It's changing it as I see the thing get dragged. If I drag it even further, well, what's going to happen to protrusion? Is that just going to sit in free space? No, it's not. The protrusion is actually going to hop over the surface, and the round is going to hop over the surface as well, because it's understanding that that's exactly what I want to do. So you can see here just how powerful things are. Not only can we change things from a XYZ perspective, we can also maybe add angles onto it. You notice this is completely not taking into account the previous design intent, because that's now obsolete. I could go back and revisit this later on and build dimensions if I see fit, but I haven't had to worry about that during the design review, where we're just interested in changing the geometry so that we've got a new concept. So again, what's happened to the existing assembly? Well, if I was adding features here, then that assembly would fail, because it wouldn't know where to put this boss. But because I'm just simply modifying surfaces, hey presto, my components know where they live, all of my cabling would be updated, all of my layouts would be updated, as would my drawings. You know? So there is huge benefit in just modifying this existing geometry rather than creating brand new information. But you will notice, however, as I've spoken about before, that in the model tree you'll start to see these being built up as moves. Now, I've got some really neat other selection techniques which I can use here. So for example, if I want to move this boss, which again I do need to do because that's exactly what the project manager has said, rather than having to select holes and cuts, etc., I've got the ability to go and scan the whole model around things like coaxial, whether things are coaxial, whether things have got the same radius or the same convexity. So I just say, right, I've got some coaxial shapes there. That very, very quickly gets all the surfaces which I'm interested in. So it's got not just the surfaces at the top, but also those at the bottom as well. Again, we can move that around by dimensions. So if I say, right, let's build some intelligence here through dimension, I've got an additional reference which I want to select, which is this central datum. Oops, which is this central datum even. And then the dimensions is going to be from that axis to that face. You can see there that we're starting out building up dimensions. We can add additional dimensions, so I can pull the thing around in whichever way I like. So again, let's just select that axis, and let's select the side face, and you'll see that we've now got 2 dimensions into the center of that. And of course, their tolerance, we can put limits and fits on there, we can put geometric tolerancing on, etc., etc. It's also now just a standard parametric feature. So what we'll see down here is that we've got this move, and if I just edit that, you'll notice we've got these dimensions, and using the standard pro-engineer techniques, with real-time regeneration, we can pull this thing around. But again, what happens when this round interacts with the other sets of rounds? That's not a problem for it to work out at all. It just modifies it as it sees fit. So it's hugely powerful. And it's also giving me very predictable results. I know what's going to happen. It's not throwing wobblies around, not being able to intersect things. That's all very happy. So as a design engineer, I'm starting to look pretty happy. I'm pretty cool. But the next thing that I need to do is work with this boss underneath. Now, the way in which this boss has been constructed underneath, if I just show you the dimensions, we can see that first of all I've got a little hole there. Okay, that's cool. And let's just have a look at this. Oh, crikey, got those dimensions. So if I were to start to change the size of this, sorry, if I were to start to change the size of this, rather than edit on that, and maybe start to pull this thing out, you'll notice how the geometry is changing. So it can only go so far before it fails. And my project manager wants this thing to go out, much further than that. So how on earth would I go about doing that? Well, again, that's not a problem when talking about flexible modeling. With flexible modeling, I'll have the ability to not worry about those resulting bits of geometry. So again, I can say, well, take this and take the geometry on the other side as well. So we can see there that it's got the through cut. I also want to just take these additional outside surfaces. And again, I just want to move these around. So I just move them around by dragging this time, so we've seen the dimensions. Now, as I start to pull this out, I would hope, as you would expect, we'll pull these surfaces out, but this surface will change because of the attaching surface. So as I pull it out, everything updates. Now, clearly that's not really what I want, because I'd like these to be nice and straight, because that makes my manufacturing much cheaper. So I can change the way in which it maybe attaches. So I can say, well, what I would like to do is create some side surfaces on this model, in, for example, here and over here. And we start to see that we get these side surfaces which are nice and straight. Now that's not necessarily left the prettiest of geometry in the world, because it's left these kind of cutouts which not really necessarily what I want. But again, with flexible modeling, that's not a problem, because I'm just interested in geometry. So I can say, well, get rid of that. And get rid of them as well. So you're removing geometry here. We're not removing features, we're removing geometry. And of course, that's now all ready for me to go ahead and create rounds and make my project manager a really happy chicken. Fantastic. So that's all looking pretty happy to me. Right, the last thing you wanted me to do was substitute these surfaces. Now, I've always been able to do a replacement pro-engineer since the year I've been able to say, take this flat surface, replace it with this surface. But what I haven't been able to do is say, take these three surfaces. That's exactly now what I can do with this substitute command within the flexible modeling toolbar. So I can now say, when I substitute, I can say the surfaces which I want to take off is maybe this one, and this one. Everything as you'd expect is on the right-hand mouse button. I want to substitute it with this one. And what we'll see is that all the rounds which are sitting at the base of this will move onto that new feature. So all those rounds which were at the bottom of that rectangular section, sorry, that triangular section, have been simply moved onto the round section. Right, so as a design engineer, I think I've satisfied all of my my design review criteria. So let's just go and talk to the project manager about the assembly, make sure he's happy. And he says, yeah, that's all looking cool. Can we actually, as a project manager, I'm interested in what the bolt looks like down here. Can you just chuck a quick bolt in there? Yeah, that's not a problem for me to do at all. You know, being the great engineer that I am, let's just stick myself an M5 20mm bolt in there. So I got myself a, it's a bolt. So we'll just say, let's just assemble it as we would normally expect to assemble it. There you go, Mr. Project Manager. There's your bolt. Do you like that? Mr. Project Manager says, yeah, that's quite cool. Can you pattern that for me? Yeah, well, the patterning capabilities in ProEngineer, as we all know, sorry, in Creo, as we all know, are tremendous, so I can just ask it to pattern it. I don't have the ability to reference pattern it. Now, why is that? Of course, we all know, we're all existing Creo users. We know the reason for that is that this is not part of the pattern. So if I go and have a look at how that's been dimensioned or created, okay, that's problematic. But not when I'm working with flexible modeling. When I'm working with flexible modeling, I can simply ask Creo to say, well, take this surface, go and recognize some patterns. You'll notice there that it's recognized the patterns throughout the model. And when I then go back to my assembly, I can say, well, take this nut, because of course we've just modified geometry, pattern it, it's now a reference pattern. There you go, Mr. Project Manager. You happy? Yeah, he's happy. Fantastic. So the last part of the demonstration, just in conclusion there, hopefully what that's really showing you is that you can just take any geometry, independent of source, independent of design intent, and modify it and repurpose that for future needs to really explore new concepts and come up with those concepts much more quickly than you would if you were just working with parametrics. Now, of course, the next thing I need to do is defeature this and give it away to my my guys in the world of analysis. So, if I want to give it to the guys in analysis, then they may say, well, okay, let's just delete some of these features. Well, the problem is that if I delete the features, then I need to deal with parents and children. So I say, let's get rid of this. I've got all these children I need to deal with, and I just, you know, I'm not an advanced user as a CAD, as a CA chap. I just want to get rid of some geometry to make this thing simpler. Again, with flexible modeling, it's very easy for me just to say, well, maybe take this, find everything of the same as the equal radius. Yeah, so that's got all my holes, and I can simply remove them. So of course that will analyze much more quickly without all those holes than with them. We can do the same maybe for this boss. So again, just like we did before, we can say, well, take the everything with the which is coaxial. Yeah, maybe take the top surface, take the bottom surface, and again, let's just remove it. And again, we can see it just gets rid of that geometry, but it hasn't deleted it, because what we'll see is down here in the model tree, we've got these features called remove, so we can get them back at any time. It's different from suppression, because suppression you need to worry about your parents and children. It's simply removing geometry. So you can see how easy it is now to run my analysis in a much simplified form. We can also, as you would expect, group these things together. We can add them to family tables. We can suppress them. We can get rid of them. So if I do suppress and want to get back to my original design, that's really quick and easy for me to do. Which typically, if I've been deleting those features or even suppressing and reordering again and redefining, it just wouldn't have been possible. So really what we can see there is that, again, when we're defeaturing models, we're actually adding additional features to get rid of geometry, which again makes my design much more usable by people further down the design chain. So that really brings me on to a conclusion. The solution to this agile design is Creo Flexible Modeling Extension. It's got some key capabilities which enable you to be highly agile. You've got all these fast geometry editing techniques. You've got move, remove, attach. We've got the fact that all of these actions are recorded as features in the model tree, which means that they can be modified later and used as normal parametric features. And because they're features inside the tree, all the old design intent is all completely preserved for you to either get back to it or repurpose it either at a later date or just not worry about it. So really the benefits that this brings to the business is it hugely accelerates the concept and detailed design phase of any product development. It makes editing parametric designs much faster, much easier, and enables you to edit content from other systems which previously you wouldn't be able to work with. It enables you to work much quicker with design exploration. You know, what-if scenarios. What if I move this from here to here? What if I add an angle on it? And of course, it also makes the preparation for models much, much easier for downstream applications. So hopefully this webcast has been interesting and informative. Hopefully it has sparked some seeds of interest in you. If I can ask that if you want further information, you either look directly on the PTC website or contact your reseller account manager or your PTC account manager. So really what I'd now like to do is draw that to a close. Thank you very much indeed for your attention, and really open the floor to any questions. So as we spoke earlier, the questions are in the questions and answer box. So just going through these, if I can see them somehow. So I've got a number of questions, and I'm having problems actually seeing them. Maria, how do I go about seeing all of the questions? All right, yeah, I see them. So first of all, from Jerome, okay, after Creo licenses are still needed to open and import Inventor and/or SolidWorks files. Absolutely, you still require the correct module to be able to open or import third-party CAD. So whether that be SolidWorks, AutoCAD, JT, Inventor, etc., etc. Another question is, when passing data to another party, do they need flexible model extension to read that data, and how about edit it? When passing it, so if I've got a model which has, and that was asked by Mike, if I've got a model which was which contains flexible modeling features, I can read that in any version, in any flavor of Pro Engineer. They do not need flexible modeling extension. They can also modify those features, so they can change the dimensions, they can change the parameterization within them. But the one thing which they can't do is redefine those features. So hopefully that's answered your question there, Glenn. Sorry, Mike. And I think we've got one other question here which we've got time for, which is, does creating new features every time you have a feature make a detrimental effect to rebuild time? Well, absolutely. The more features you have, the more your rebuild time will be. But conversely, quite often, rather than just creating more and more and more moved features, you can modify existing features. So hopefully that's answered your question, Alistair. So really that's drawn everything to a close. Again, I would like you to thank you for your time, and hopefully in the next couple of days this webcast will be posted onto the PTC website, and everybody on this call will be notified of that URL. So thanks once again, have a great afternoon, and I'll look forward to seeing you inside the PTC ecosystem. Bye for now.